presentation tonight. Good answer. So, because I'm a man, so I looked into all the different books and I looked into a variety of different things. And you know what? They don't want you to write out all those stupid polymers. But I said no, so I'm still going to keep it off the test. But for an ACS exam, you'll want to be able to do polyvinyl chloride, polyethylene, whatever 3, 4 ones are in the book. Okay? And I looked at what I did last year, and I had a couple of questions on there, so I told Ezra, we're going to scratch them all out. So focus on everything else, because in all honesty, your nomenclature is number one. Okay? Your physical properties, you know, what's more polar, what's less polar, and then your reactions. And your polarity will eventually get you to where your reactions aren't really so nebulous and what the heck is going on. Okay? So, and that's in essence just kind of what we've done in class. It's not on the test, and I do know that at this point, usually, well, let's do this. How many are freshmen? It's got to be just about everybody. Not everybody. Wow. Okay. So, but this is probably, how many of you had your pathophys or your anatomy? Okay, so this is going to feel a lot like anatomy, where there's a lot of muscles and bones you've got to memorize and so on and so forth. I think it's kind of, nobody's had their pathophysiology yet, right? Probably, or you're starting it here now, and so you're in the honeymoon phase. Is Tufty's here? She's alive and kicking now.
She's still sick.
So she's warming up. No, she's not as tough as she portrays. But, okay, so that's going to be a good class. This is going to be, yes, those of you having pathophys are going to enjoy your time. It's a lot. All right. So we're going to keep that. Yes, so somebody asked this question, so I'm just going to start out with it because I think it's something that gets lost a little bit. Give me the name for each of those. And you look at that, and it's just like, well, yes. It's that sharp mind of remembrance. Yeah, and so this is going to be the paratoluene, and I would actually give you, because the IUPAC allows it, even though your book may not talk about it, this would be 1, 2, remember those, the longest continuing chain? That is the heart and core of the IUPAC system. So, and the American Chemical Society will use the IUPAC system. Okay? Which means that you might get the para on the test, but you might also get the 1,4 xylene or 1,3 xylene. But this one here is the metaxylene, right? And then this here is the ortho xylene. And that's a common theme, orthoxylene, I'm just going to spell it how I ever do, that when you get only 2 groups on it, if they're in the 1 and 2 position, they're ortho. If they're in the 1, 2, and 3, if they're in the 1 and 3 position, then that's meta. So it's also possible to, what happens if I change this to a chloro group, and this to a bromine group, and this to, let's just make this would be, I would consider difficult. Because now you're mixing 2 of your special named ones, right? Question, someone had a question. Yes?
You said toluene on the first one.
Xylene, excuse me, yeah, those were xylenes. Did I say toluene? You said toluene, it's okay. It's toluene pairs. It is xylene. But toluene, so that's the point, is sometimes those common names are kind of ridiculous. Especially those that are named after people. I don't know if I told you, probably told you about the barbiturates. Did I tell you about valeraldehyde? I don't get that. In all honesty, there needs to be, so here's the deal. I'm gonna start a scholarship for women in science. I believe that there needs to be more women in science and go out and name things after male names. You know, like vomit should be named after, this is bobatane or something, boboic acid, tomoic acid. All right, so any question you have, either in the book or wherever, this is your time. And so I can tell you about the test. I do have extensive, there's nomenclature, naming. By the way, naming is called nomenclature. So there's naming, there's nomenclature that you will write out like this, and then there are names that you will draw. There are a ton of multiple choices, because again, I know that this is probably, I don't know, has everything else been kind of the general eds for you? This is usually for this class, usually mostly freshmen. Some might have had the anatomy, but this is usually the first class that really you feel like you're just off and running. But it is, you know, there's the content. And I'll tell you honestly, we're cutting, we don't have time for one chapter. We have to cover about a chapter a week, but they've shortened this from 15 down to 4. So there's one chapter that's the simplest chapter that we'll just say prior to if we get some time, we'll do it. But we'll just say prior to your ACS exam, just go in and read that chapter. It's about recognizing adenine and another nucleotide, so on and so forth. So it's a very short chapter. But we'll cover all of the meatier, the heavier chapters. And it's a lot. I'm not going to lie to you, this is a lot. But this is for those of you that probably in pathophys, you'll probably say, if you've had your anatomy already, you'll say, no, this is a little bit easier than pathophys. Pathophys is that's a carboxylic acid as a functional. Good answer. Now, the real question here, though, is this is also one of your special names, benzoic acid. And so here's the unsaid thing about those. And I noted in some of the books, I went to look through all the books, that they put the two together. This then would turn into a methyl group instead of a toluene. You know, and so there is an order. Methyl is the lowest. The order of priority is carboxylic acid, then your aldehyde, which is your benzaldehyde, okay? Then your alcohol, which is the phenol, if we put it on here, and then your methyl group. So if you ever had one of these, if this one was with one of these, like you had this, then that would be a hydroxybenzoic acid. That's how that goes. Now, I haven't done that to you, but what I'm saying is, each book has its own little thing, and so I'm going to stick to your book. But I'm also going to give you what 8 out of 10 books have. I may not test on them, but I'm going to say, this kind of stuff will be on your ACS exam. And that's what they do to use and separate things out. The ACS exam is not written so that everybody gets 100. It is written so that it filters everybody out based upon their work habits and work studies. You know what I mean? I mean, some of you are going to put an hour a day into this class and say that I'm busting my butt. Others are going to put 3 or 4 hours a day into this class and say it's not that bad. I've got 3 or 4 hours in here and 3 or 4 hours there. It's all a matter of your perspective. And right now, many of us are still relatively new to the science courses. So this may feel like a lot, but it's like Selwyn said, this is actually going to be one of your easier classes along the way. So I think this is about the same level of anatomy, because there's just a lot of memorization. But pathophys is a little bit worse. But good for you guys. Anyway, so that's just one of the things that you do see. It's not there. As we go farther and farther up, you will recognize that we're going to talk about aldehydes and ketones down the road. And so at that point is where I will, and you didn't see me mix these into the class, right? See, when we talk about these, and you know that it's the highest priority group, because we're starting at the end in terms of nomenclature for that, then you'll be able to see, all right, I get that these have higher priority, and I'll bring these back in for you, and it'll be closer to the ACS exam. And I would believe that your book probably, in other words, your book didn't do them now, or some books did it now, but I think your book will bring it in these chapters. Does that make sense? Okay, so enough of that preparatory work. Let's answer all your questions and alleviate your fears. I am yours. You are mine. We are walking.
Don't erase that first one.
Oh, okay.
Can you name that?
Yeah, so this, I would name it as a parachlorotoluene, okay, or a 4-chlorotoluene. And I would consider that's just the one, that's right there in those challenge type questions. All right, any other questions? Questions? Problems in the book? I brought my book. Yes?
In chapter 12, question number 64 and 65.
Chapter 12, back to the book, question number. Number 31 and 35?
No, 64.
54 to 55.
64.
Good grief. It's all those years. I will be honest, I was a musician early on, 10 years in loud venues, and then because you have a studio, you DJ. So I retired from DJing, so I have right there in the shop. 64 and 65. All right, so 64 is write the formulas for 3 singly chlorinated isomers formed when 2,2-dimethylbutane reacts with chlorine in the presence of light. All right, so the first problem is 2,2-dimethylbutane. 1, 2, 3, 4. 1, 2, 3, 4. And 2, 2. There's my methyl. So there, this is 2,2-dimethyl 1, 2, 3, 4 butane. Is that what it was? 2,3-dimethylbutane. Okay, and so how this would look would be Cl2 and light. So this is that radical reaction that's at the very end of chapter 12, I think. I think it's on page, oh, look at that. Look at the chapter. So look at page 382. Oh, yeah, so it's on page 383. 382 has a little blurb on what we were trying to do. That's that Lewis-based curved arrow formalism that we'll keep showing you. That really, if you can get a handle on that in recitation, because that's all the book gives you is that will help you predict all of these reactions. All right, so what you know in there, and this is a good thing, you have to understand, note that all they've really given you is this. what is it, 4? Is that what they gave you? On page 383. CH4 plus Cl2. Okay? 4Cl2. Wow. So they want you to chlorinate the dog out of it. They want you to chlorinate everything. And so when you get there, what you see is a CH3Cl, a CH2Cl2, a CHCl3, plus a CCl4. Let me write this somewhere. Plus a CCl4. Okay? How in the heck am I supposed to make it? See, you're not used to this. This is the key. How do I make this extension from here to here? These don't even remotely look the same. But that's like a motor vehicle accident. None of them look the same either. And what you look at in your nursing books for examples and what you do on your mannequins is nowhere near what it looks like in real life. So this is a practice of going from something to something else. So here's what I know. If I had 4 here, how many do I have here in terms of moles? 1. So I'm not putting 4 on here. I'm only going to put 1. And then how many places can I put that 1? because this is what this said is, well, I put one on carbons and carbons and carbons until I fully chlorinated it. So here then, I would say, I don't have a hydrogen here, right? But I could put one here. And that would be one isomer.
So it's just asking.
Yes, that's, but until you've done that, you're just like, what the heck? You know, I'm gonna have to bring a horn here so I don't swear. What the beep? And that's, again, that's the difficulty of this class. That's what this class is designed to extend you to. So this is why when I deliver something, you're gonna see 3 or 4 pictures and you're gonna say, what the crap is that? That didn't look like what's in the book. No, this is the extension. And you're exactly right. Until you've done that, you're just like going, and how do I get from here to here? And I remember my first, oh gosh, my first year was ugly here. It was. It just, you know, middle school and high school overlap. And sometimes high school, if you came from a good high school and your gen eds in English and a few things like that overlap, for the most part, there's just a huge gap. And that gap just rocked my poor little world for quite a while. So yeah, this would be one isomer. This would be another isomer, and then this would be another isomer. Oh, and I could put one out here. If I put one up here, it would be the same. So there's possible 1, 2, 3, 4 different isomers, and how many did they want to see? How many? 3. I think that's a wonderful thing. When it comes to isomers, if you really want to see me struggle like you, when they get to those larger C7 compounds like heptane and octane and they say, draw the 9 isomers, I'll get to 7. And then I'm just going to look like a deer in the headlights and I don't really know. Because there's a creativity element there that you just have to see it, you have to expect it. Now there is some methodical nature to it, but normally everybody gets stuck on those last 2. Wow, that's a good question. All right, anything else? I'm having fun. But then that's why I do this. Because if I didn't enjoy this, I wouldn't do it. Yes?
So let's start with this solution. Ezra just kind of drew out the basic products of reactions given certain reagents.
Mm-hmm.
So, how you've been explaining it with your lifelong question, do you want us just to memorize the products of reagents, or do you want us to understand?
So, in all honesty, the test and what this class wants is just that memorization. What I'm after is for you to do really well, though, on that ACS exam, to be above average, above the 50th percentile, okay? And to be as close to the 90th percentile as you get. There will be people in here that will get 98, 99, and I'd like to see the whole class come into that realm. So the electron pushing, while I'm not going to test on it, is there to help you, because once you get a handle on that, then you can predict those reactions you've never seen. And that's a big value. So when you get to the next chapter, you'll just look at that and go, well, that ought to go there. Oh, it does. And so I'd like that, but I'm not going to test on it. So I don't really know if they're going to come in and say, you know, here is an alkene, and here is HBr, and here is HCl, and here is acid and water. And so if we're just taking the alkenes, okay? So as you go through these and you look at them, your book will eventually, if it hasn't already, come in and say, okay, how would you synthesize this compound? Okay, how would you synthesize this? And have you read that in any of the problems yet? Probably not so much. Eventually it will get there. And so what I would do is, as I practice my reactions, okay, so in other words, I'd write all the reactions in the book out on a page, and then I would do them. Okay? And then I would cover this up, and I would say, okay, how do I make that? And that way, when your book starts saying, how do you synthesize this, you've got it both ways. Because it will eventually get there. Now, in terms of the pushing electrons, right there on that page, they give you that 382. I do like McMurray for this. On 382, he talks about organic chemistry and the curved arrow formalism. I'm going to continue to have Ezra in recitation go over that and help you with those pushing electrons, because I do know that there was about, last year, probably 8 or 9 that really got it, and they did actually, those were the ones that were sitting there in that 90 to 100 percentile on the ACS exam. Because when you're just memorizing, think about it now, you had anatomy. A lot of you had anatomy. Let's say you took a national standardized test on anatomy and you had to name, you know, all the bones and all the muscles. Could we do that? I know I couldn't, because it's a memorization thing. This type of, this is an extra electron, and this is my Lewis base, and this is pulling electrons away from it. We can all see that, so that if this is pulling electrons away, then this is really almost an H+. That makes sense? Which means that these pi bonds will pick this up, and that's going to give me a carbocation, and then I'm going to have Br minus. Well, a plus will go to the minus, and that gives me that. Okay? And if I do the same thing here, that tells me how I get that. And if I do the same thing here, pick it up, get the carbocation, and of course, I probably should draw for the first little bit in here. This is where the hydrogen goes, and this is where the hydrogen goes, because I'm picking this up right here, you see? And so that hydrogen is getting stuck to that carbon. And so in all of these, that's how I get to that. So down the road, let's say if you had an ether chapter, H plus and say CH3OH. Again, we could just memorize that this is going to come and make up an OCH3. That would be an ether functional group. But we could also say, I'm picking this up. That means I'm going to come to this carbocation, and here's the hydrogen again, and then this is my Lewis base. It comes into here, and so there we go. There's my OCH3. You see a pattern there. And that pattern you can predict. And so when it comes to a standardized testing time and you're stressed, that pattern is what saves you and keeps you from memorizing. So that's the value of what he's doing in recitation and working forward and backward. And he's good at that, and that's what I told him to do, because that really makes it, if you really want to learn it, it's above and beyond the class, but it does help you immensely. Yes?
How would you name
This one here? So, you remember your isopropyl group? And a methyl group here. This is actually,
that? Isn't that a nucleon?
yes, this is a, let's see, let's go HIJK. So it's alphabetical, right? This is an isopropyl methyl ether. So ethers are named quite nicely and simply. You just put the names on them. You know, so if I had an ethyl group and a methyl group, how would you name it? Ethyl methyl ether bunny. Oh, come on, that's just. Okay. Wow. Ether bunny with a hangover. One crooked eye. All right, back to this test. But that's the value of what he's trying to do, and then pushing electrons going forward. All right, any other questions? Yes?
Chapter 13, number 27.
Chapter 1327, right? Very good. Look at that. Heard it. 1327. Oh. 22. Draw the product from the reaction of the following substances. Wow, do we have to use models? Okay, so my agent's going to come and take my glasses off now so that I can see up close and personal. Oh, speaking of an ether, and another ether,
Predict the products from the reaction of the following substances, one with Br and FeBr.
So I'm just going to do them up this way. So this is Br2. Is that going to drive you nuts if I do it this way?
No.
And go up here?
So if I'm going to get that guy,
I like that they've at least done this. So here's my ether. And here's my ether. And then I'm going to have a bromine here. Now, whether you put the bromine, so if this has an answer in the back of the book, you need to understand if I put the bromine here, that's the identical as if I put the bromine here. And if I put the bromine here, that's identical as if I put the bromine here. So if you just put a bromine on it, anywhere you put a bromine on this one, it's perfectly fine. Because it's symmetrical. Down here, and so that would be the same also if I do SO3 and H2SO4. The only difference would be is that this would be an SO3H. And you could put it here, 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 or here. And I like this because you may have put it here, or you actually probably would put it up top because it's just how you do things. But your book is saying, do you recognize? Remember when it took a compound and just moved it all around here and asked you if it was the same compound? If it has the same name, it's the same compound. And so let's just pretend that this was xylene. This would be a orthosulfoparaxylene type of thing. And if it was here, it would still be an orthosulfoparaxylene. So it had the same name no matter where it was at. It was a bromine. Does that make sense? So it doesn't matter. The real kicker, and this is what will cause you all sorts of stress and headaches, is that you're not quite used to putting something here. Okay. Putting, say, a bromine here versus a bromine up here, and recognizing that they're exactly the same compound, because your eyes say, no, they look different. One was at the bottom to the left, and the other one's right at the top. Correct? But your naming ability, if it has exactly the same name, then it's the same compound. So, for example, let's do, what's this compound? Let's name it. Well, we got to be quicker than that, right? 3-methyl-heptane. All right. Probably should leave this like this. So this is the first one, 3-methyl-heptane. All right, so what's this one? 3-methyl-heptane. Okay? So at that point, that's them trying to say, whether I put the bromine here or here, it's still one away from it, and it's still one away from this one, and 1, 2, 3 away from that one. So they're exactly the same compound. So what I'm saying is, one of the biggest things that right now will cause you an insecurity is you draw something like this, and you go to the back of the book and it dropped down the bottom. The first thing you're going to say is, wait a minute, why is that? And you're going to think that you did it wrong. How many of you have experienced that? I got that all the time, so a third of you. And that used to just drive me nuts until I really got into the naming. I like that this book has you name right off the bat, so that when you get to the naming, you can say it's exactly the same thing. So, on your first one here, BrSO3, okay, so those they go in the same spot, just different reactions. So this is the SO3 and H2SO4, and so that's going to be the SO3H here. Okay? Now, if I do it here, same thing. If I do the bromine on here, you would probably put some bromine here, and that's okay. The book might put the bromine down here, but that's still okay. So if I do this compound with Br2 and FeBr3, I'm going to end up with Br3 here.
And then if I do it with SO3 and H2SO4, yeah, Br. Good answer. You see? You should take my dollars. It'll be a 6-pack.